Hello, hello. This is a continuation of my slope series. If you did not watch the introductory video on slope, go ahead and watch it. We're talking about slope-intercept form today. This is a special type of form. My question is, have I seen this equation before? Many of you have been in an algebra class before or have seen just this formula, maybe heard someone say y equals mx plus b. That's all they remember from Algebra 1. Who knows, but this is my slope-intercept form. In this form, y and x are going to stay variables, but m and b are going to become numbers. That's right, m and b are going to become numbers, but x and y are going to stay variables in this equation. So using slope-intercept form when given a slope and the y-intercept, well, my form is y equals mx plus b, where m is my slope and b is my y-intercept. So if I substitute -2 in for my slope and 3 in for my y-intercept, I get y equals my slope of -2 times x plus b, my y-intercept. And that is your equation of a line in sloped-intercept form. This line, y equals -2x plus 3, will have a slope of -2 and go through -3 on your y-axis, positive 3 on your y-axis. It will cut through at positive 3, or the point 0, 3. So down here, it already says m equals -1 and b equals 15. So y equals -1, or y equals m x plus b. Why this is okay, just saying y equals -x plus 15, this is better. This is what you want your answer to look like. You don't want to have a 1 in front of that x. That's not how you'll see it really anytime it's written formally. So y equals -x plus 15. So using slope-intercept form when given a graph, this is what you guys are going to see most often. What should I do when I'm given the graph of a line? So let's say you got this graph and it has this big old line, or it has a big old line. The first thing you want to do is find the y-intercept. This is the first thing is the y-intercept. Then you want to find a point on the line with a nice cross. That means if this is your grid, you want to find a point that crosses in a nice cross. You'll see what I mean in a minute. Then you want to count the rise and the run to get from your y-intercept to point 2, or to your second point. That rise over run is your slope, and then you can substitute your slope and your y-intercept in for m and b. Let's see what I mean. So question 3 gives you a graph, and the first thing I want to do is find my y-intercept. Well, my y-intercept is right here at positive 1. So b, or my y-intercept, is positive 1. Now, how much do I rise to get from positive 1 on my y-axis to my next point? I rise 1, 2, 3 units, so my rise is positive 3. What's my run? How far do I have to go to the right? Well, I go to the right 2 units. I'm going 2 units in the positive direction, so my run is positive 2. Well, my slope is rise over run, so positive 3 over positive 2. So the final answer, my equation of the line, is y equals m, which is 3 over 2, x plus b. This is the equation for that line. Let's try this one over here. First thing I do on question 4 is find my y-intercept. My y-intercept, my b, is actually at negative 3 on my y-axis. Well, now to get from negative 3 to this point over here, I have to go down 1. I go down 1, and that is going to be my rise. I rise in a negative direction, and then I run 1, 2, 3, 4 units to the left. Since I'm running in the negative direction, my run is negative 4. Well, slope is rise over run, but if I'm rising negative 1 and I'm running negative 4, those negatives are going to cancel each other out, so my slope is actually positive 1 over 4. So when I go to write my final equation of the line, I have y equals mx, well, m is 1/4, x plus b, well, b is negative 3, so you could also write this y equals 1/4 x minus 3. And that is the equation of this line. So we have 2 special cases. The first one is I have a horizontal line. What's the slope of a horizontal line? Isn't the slope 0? So if I look at my y-intercept, or my b, is negative 3, and my slope, or my m, is 0. I'm not rising or running at all to get to my next point. Sorry, I'm not rising at all. I'm still running, but I'm not rising. So my slope is 0. If I write this in the equation, y equals mx plus b, well, what's 0 times anything? Isn't that just 0? So y equals negative 3. This is the equation of that line. One of your special cases is horizontal lines are always in the form y equals. Write that really big. Horizontal lines are always y equals. 0 slope is just y equals whatever the y-intercept is. So y equals negative 3. You also have vertical lines. Vertical lines have what kind of a slope? Undefined. Good job. Well, my question is there a y-intercept? Do I ever cross the y-axis? No. There's no y-intercept. So if there's no y-intercept, how can I have a y in my equation? This is where we get to my special case number 2. If I have a vertical line, that means the slope is undefined. Wherever it crosses the x-axis is going to be what x equals. So in this example, it crosses the x-axis at positive 2. So my equation is x equals 2. There's no y. Sorry, that 2 is a little wonky. There's no y. Intercept. I have an undefined slope. So x equals 2 is the equation of that line. And what that means is it doesn't matter what y is. Y could be 5, y could be -2, y could be 0, y could be infinity. X is always going to equal -2 no matter what y equals. So these are my two special cases, and these are graphing or finding slope-intercept form given a graph and given the slope and y-intercept. Go ahead, try these on your own. Have a great day!